So with Miss Hendrickson, you guys went through solving linear inequalities. Just a refresher on that. Inequations are equations of statements of inequality, and they represent a portion of a number line. So what this means is that rather than just being one point on a graph, it represents a range. So for example, x is greater than 2. It means that all the x values that satisfy this inequation is greater than 2 and not including 2. So that on the number line will be represented by a hollow dot and a line with an arrow towards numbers that are greater than 2. On a Cartesian plane, similar to this, rather than a hollow circle, we use a dashed line to represent this. So when it's a dashed line, it does not satisfy the inequality, so it's not included, and usually we have the less than and greater than symbols. When it does satisfy the inequality, so when the number is included, then it's represented with a solid line and it'll have a line under the symbol. So on the graph, we also need to make sure that we show which region is the required region. So the required region is where they contain all the points that satisfy this inequality. I like to use the first type of shading where we use no shading to indicate the side that is the required region. So I prefer this because when you're shading, it kind of feels like you're crossing that side out. And then the region that is left over is where you will find the solution to the inequations. So let's go through some examples. So for this equation here, we have to first sketch out the graph, so the inequation. And to do that, just like the graphical method, we make x equals 0 and y equals 0. Y is greater than 2, and then x is less than negative 2. So not worrying about the symbols right now, we just sketch the graphs as it is. So y is 2 and x is negative 2. Then we draw our boundary line. So this line will have to be dashed because it does not include x plus 2. Once we've drawn this dashed line, this symbol is the symbol that tells us that it needs to be a dashed line, by the way. Once we find that, we pick any point. I like to pick 0, 0, and we can see from this that that is false. 0 is not greater than 2. So anything on this side, I'm going to shave it off. So the required region becomes the region that is unshaded. So I've left it. I'm going to go through this example here at the bottom, 26. So just like the first example we went through, we're making the x equals 0 to find y. When you divide a negative number, you have to change the symbol So you have to switch it around. This is the only thing that you need to look out for, and it only applies for negative numbers when they multiply or divide a number. So that's our y. And that's our x. Plotting them again. -4. And 3. Our symbol is not including these numbers, so we use a dashed line. Then we pick a point on the region, on either side of the region, so I pick 0, 0 again. And that is not one of the solutions because this is untrue. 0 is not greater than 12, so this region here is not required. So our solution should be on the unshaded side. For 25, very simple. We don't have to draw our x. We don't have to make x equal 0 or y equal 0 because we already know what they are. So y is, reading this, y is greater or equal to -3. So at -3, draw a line. That's a solid line. And then for question B, x is greater than 1, greater than or equal to 1, so a solid line as well. Now on either one of those graphs, I'm going to pick 0, 0 again. You can choose any point, but I like to use 0, 0. And y would be 0. So y is greater than -3. That is correct. So we shave the bottom here away. X is, so using this again. So x is 0 and 1 is there. So x is larger than 1 or equal than 1. That's not true. So I'm shading this side away. So in both of these, my required region is the unshaded area. So hopefully this was helpful, and don't forget to ask me any questions if you do have any. Thank you.